So what I'm going to go through is probably the first two examples here and kind of walk you through how to do these types of problems and what you should focus on. So again, mass spec is going to give us essentially what the formula is for the molecule that we're looking for. So we want to look at the molar mass peak. That's really the only thing we're going to look at. You're going to see after we get through this, I'm just going to usually give you the molar mass peak. So it's 72, and I'm giving you the percentage of carbons and hydrogens. So see if you can calculate what the formula is. I'll come back and show you the answer. So again, I did it the maybe a longer way. I end up with a 5 to 12 relationship. It comes out when you do it this way, you get 1/1 versus 2.4. So multiplying it by 5 will get a total whole number. So you end up with C5H12. So when you're doing this, what you're also going to see in this packet is on the next page, okay, is an IR. Okay, so it kind of gives you some help with the functional group. So this is all comes down to like solving a puzzle, and how you solve a puzzle is kind of an independent, everybody does it a different way. So you could do a degree of unsaturation here, giving me a 0, so I know that this is an alkane. But I also know that this is an alkane just by the formula, because I know alkanes are CnH2n plus 2, and that's exactly what my formula is. So I know this is an alkane. I know that also by the fact that this CH bond is below 3,000, and there's nothing else marked here, and I will always mark all of the important bands that you need to look at. So this is telling me it's an alkane, but realize that with all of these types of problems going forward, you kind of want to incorporate everything that we were learning with organic chemistry and just use this as another piece of the puzzle. Okay. All right, so that is the answer to number 1. So number 2, please flip to number 2. All right, so you see the molar mass peak here is 88, and here is your percentage. So see if you could calculate that. I'm going to pause the video and then take a look at the IR as well. So you end up with a formula of C5H12O, and this comes out pretty nicely. The numbers don't come out all that strange. So I do have 1 oxygen, so that's going to tell me something about the functional groups, some options that I have. Also note that the degrees of unsaturation is 0, so I can't have a ketone, I can't have an aldehyde, maybe it's an ether, maybe it's an alcohol. I have to look at the IR and kind of figure that out. So if you look at the IR, and I kind of drew it in, it was kind of one of these IRs, it just doesn't work out that well. This is an OH peak, okay? Anytime you see a nice smooth, it didn't come out very good in this IR. Who knows what they were doing with their solvent that they were using. But you should have a nice distinct OH peak here. So that's telling me I have an alcohol, and there's nothing else here that's giving me any other information, if it's an ether or anything like that. So it's got to be an alcohol. And again, we still don't know a huge amount of information on this molecule. So we don't know branching yet. So that OH can be anywhere in that molecule. So as long as you have 5 carbons in an OH, you're going to be fine with what I'm asking for at this stage. But the next technology that we're going to look at, the spectroscopy, is going to be NMR, and that's going to tell us more. All right, so why don't you try number 3? 102 is the molar mass peak. And take a look at the IR. The IR will help out a little bit for this one, so try that one. So this one, I'm showing you the percentage way, where you just take the percentage and multiply by the molar mass peak. This time it's a 102. So I end up with a 5, 10, and 2, which does add up to 102 very nicely. So 5 carbons, 10 hydrogens, 2 oxygens. So 2 oxygens lends itself to some interesting functional groups. Of course, we have carboxylic acid, we have esters. My degree of unsaturation happens to be 1 here. So what I'm looking for is it a carboxylic acid or is it an ester? Okay. So going back to your IR, realize that a carboxylic acid would have a huge big peak over here, which is not evident, okay? I just have this peak at 1742, which equates to an ester. So again, that's where we're gonna use both mass spec and IR together to kind of give us more and more information. So again, all I want you to do is to draw an ester. How many carbons you have on either side is irrelevant at this point. We will get more information once we get to NMR. As long as you draw an ester, you have completed the problem. So I'm going to pause the video and then I'm going to show you the answer key to the other ones. I'm not going to walk through them. So this is number 4. When you do the percentages, you end up with C2H6O. That adds up to a molar mass of 46. So it's a pretty small molecule. Degree of unsaturation is 0. You got 1 oxygen there. So you end up with an ether. You don't have a big OH peak over here on the left. And this peak that I labeled there kind of tells you that it's an ether. But again, to kind of eliminate other functional groups is kind of how you do this. Then to number 5, a molar mass peak is 100. It turns out to be C6H12O, so you do have 1 oxygen in there. Degree of unsaturation is 1, so you got to think aldehyde or ketone. It turns out to be an aldehyde due to the fact that this peak here is at 1735, and so aldehydes tend to be in that range. Again, 1700 peaks are going to be very critical for aldehyde versus ketone.